We like to think of science as this pure meritocracy, right? Where the best ideas just naturally rise to the top, no matter who came up with them. But what if, even at the very highest levels of achievement, there's a stubborn disparity between men and women? New research is suggesting this isn't just about the number of people in the room. It's something that's literally written into the very structure of how scientists recognize each other's work.
Researchers have a name for this, of course, a glass ceiling. It's this invisible barrier. And we're not talking about just getting your foot in the door. This is about what happens when you're already one of the most accomplished scientists in the world. It's a barrier that, as they put it, fundamentally limits professional recognition.
So, the big question is, can you actually see an invisible barrier? I mean, if it's real, it has to leave some kind of trace, some kind of fingerprint in the data, right? Well, that's exactly what a team of researchers set out to find. So let's follow the clues they uncovered and see what they found.
To find these clues, the researchers didn't just look at any group of scientists. They went straight to the top, the absolute elite, members of the U.S. National Academy of Sciences, or the NAS. Look, getting elected to the NAS is one of the highest honors a scientist can possibly achieve. So, if there's a barrier here, it tells us something really profound about the entire scientific world.
And right away, the first clue is kinda the most obvious one. Women are a pretty significant minority in the NAS. Now, this gap varies a lot depending on the field. You'll see it's as high as 42% women in psychology, but it drops all the way down to just 8% in physics. But this gap in the overall numbers, that's just the surface. The real story, it turns out, is much, much deeper. And to go deeper, the researchers did something that I think is just brilliant. They didn't just count up awards or publications. Instead, they decided to map the entire web of professional recognition. Think of it like creating a social map of science's most elite club to see exactly how everyone is connected to everyone else.
And the way they did this was by building what's called a citation network. It's actually a pretty simple idea. Every time one scientist cites another's paper, that's a form of professional recognition. It's a public nod that basically says, hey, your work was important to my work. So if you map millions of these little connections, you can start to see the hidden structure of an entire scientific field.
The easiest way to think about it is like a professional social network, but instead of likes and follows, the currency is citations. Every single citation is a public endorsement. And the researchers built one of these incredibly detailed networks for every single NAS member in their study, creating a unique map of their professional world.
So once they had all these maps, they started analyzing them, and almost immediately, really clear patterns began to emerge. It was like they were looking at two totally different kinds of communities, and the differences were just striking. The first clue came from the simplest measurement, just the total number of citations.
Okay, first, the straightforward clue. Even within this super elite group, male NAS members had, on average, way more lifetime citations than their female colleagues. We're talking nearly 35,000 for men versus about 21,000 for women. This isn't totally new. Other studies have found similar things. But again, this is just a number. The real discovery, the fascinating part, is in the shape of their networks. And that leads us to the real heart of the matter, right? Is success in science just about racking up the most citations? Or is there something else going on? Something in the structure of these communities that tells a different, maybe more interesting story?
Well, the answer is a resounding no. It's not just the number, it's the structure of the recognition that's different. What they found was that women's networks tended to be more reciprocal and more tightly knit. Their peers were more likely to know and cite each other. In contrast, men's networks were wider, more sprawling, with a larger number of peers, but less of that dense, interconnected clustering.
So now we've got these two different patterns. One is wider and more sprawling, the other is tighter and more reciprocal. The researchers started to wonder, just how distinct are these patterns really? Could they be some kind of signature? The answer, it turns out, was a huge yes. These structural differences weren't just some minor statistical quirks. They were so clear and so consistent that they actually formed a kind of gender-based signature in the data. A signature so strong that a machine learning algorithm could actually be trained to spot it. And here it is. This is the single most stunning finding from the entire study. An algorithm looking only at the shape of a scientist's citation network. Not their name, not their field, not their university, just the pattern of their professional connections. Could predict whether that scientist was a man or woman with 78% accuracy. Just let that sink in for a second.
The very way you are recognized by your peers has a distinct gendered pattern.
Now, you might be thinking, okay, but wait, maybe this is just about something else, like being at a super prestigious university. It's a good question, but the researchers checked for that. When they tried to use the exact same network data to predict whether a scientist was from a top-ranked institution, the algorithm completely failed. It was no better than a random coin toss. The signature in the data wasn't about prestige. It was specifically and powerfully about gender.
So what does all this mean? We've seen a numbers gap, we've seen a citation gap, and now we've seen this really deep structural gap. Why does any of this actually matter for the future of science?
Well, for starters, it means the pathways to the very top of the scientific world just look different depending on your gender. It suggests that those tightly knit networks that women are often part of might offer a different kind of support, a different form of social capital, even if they result in fewer overall citations. This tells us that big societal forces are actively shaping how science gets done and who gets recognized. And it just hammers home why diversity is so critical. Because having different kinds of networks and different pathways is exactly what can lead to more innovative and equitable science for everybody.
Ultimately, what this data does is it takes that so-called invisible barrier and makes it visible. It shows us that even among the most successful scientists on the planet, the very structure of professional recognition is fundamentally different for men and women. And that leaves us with one last big question. If the patterns are this distinct at the very peak of the profession, what other subtle, powerful forces are shaping science that we haven't even learned to look for yet?